Greetings! This is my small game made in OpenGL and C++, codenamed as Coral Sky. When you wake up, you will see yourself driving a 4x4 terrain vehicle in space on flat rocky asteroids. In order to take control of your car, you'll have to use the W and S keys to move forward and backward and steer the wheels by moving the mouse to the left or to the right. The car will try to move in the direction that you are currently looking in. By pressing the space key, you will do a handbrake, which will make the car move slower but allow you to steer more easily. At first glance, you may not be sure what direction should you go in, but have no worries, as if you look around, you will see some other flat asteroids to which you can jump without fear. In case you didn't notice this already, around us there are many smaller, round asteroids that are drifting in space. They rotate and move around randomly, but not completely. They have their own sphere colliders and are affected by each other's mass and gravitational force. Once a certain amount of time has passed, one will despawn and another will spawn randomly around the scene. To continue our journey, we'll move on to the next platform by walking over this bridge. Here we can find a small base with a generator inside it spinning furiously. The walls here are all solid and thus won't allow us to pass through them. In case you want to go back to the starting point and follow the track again, you can see here this pink man cannon. Once we touch it, it will throw us right where we want it to. Here are some things that you may have not noticed at first glance. The car is a composite object. The wheels rotate separately around different origin points based on their velocity and the user input. The lighting is made out of ambient, diffusion and specular maps. Each piece of the car has different textures and colors. When moving between these two asteroids, there is a small portion in which you will move a little slower, due to the change of friction applied onto your car. Oh, and did I forget to mention that you are a time god and you can slow down or speed up the time scale without breaking the physics? The shader class is very easy to use, efficient and flexible. To create a shader, you'll use its constructor by specifying the number of shader types and shader paths you'll use, and you're good to go. When created, the shader will load the location and type of every single variable within it and save it in a map by type and name. You will no longer to use GL get uniform location. Through the shader's methods, you will be able to both set and get the values of any variable it has. The materials are loaded at the beginning into the resources class. The standard OBJ material, cube map material, sprite material and so on. Each material will have some default values and a pointer set to its linked shader. Once a mesh is loaded, the mesh will get a new copy of the material with its own properties and values while still keeping the reference to the shader. That's why all the textured objects in my scene use all the same small shader but still have completely different colors and textures. I've been told that for an engine to be considered strong, it needs to have its physics and graphics engine separate and independent. That's how I made mine. The renderer, which is the component handling the drawing events, is just a simple component, just like the transform, rigid body, player controller, etc. It can be added to any game object at any time. It can also be removed at any time, and the game will still work perfectly, even though the mesh will no longer be visible. And not only that, the physics and graphics engines also are separate when it comes to the updating and animation. Starting to get a low frame rate? No worries, the animations will still run perfectly fine. This is a result from me using the fixed time step. The camera is also marked as an independent component, and the camera has its projection matrix updated automatically on every resize. What does that result into? A flexible window with a completely flexible resolution. Want to play a game in 4K? Just maximize the window on your 4K monitor and you're good to go. Want to play it as a phone game in a 9:16 aspect ratio or in a weird 1:1 ratio? Consider it done. The light is, just like most of the others, a separate component that can be added onto any game object. This means that you can have multiple lights in the scene and they will all add their values on each lighting update to the shaders based on their position, color and intensity, and rotation. Weaknesses? Only OBJ files can be imported for mesh loading. New material classes need to be created every time a new shader file with different variable names is created. Lights can only be directional, shaders can only accept diffusion textures, and no animations present within the shaders.